Hi guys, today we're going to be balancing equations. Balancing equations can either be the bane of your life, or it can be something that is actually quite enjoyable, given that you understand how to do it properly. Balancing equations is essential in chemistry as it underlies the conservation of mass principle, which states that matter is neither created nor destroyed, but merely changes form in equations. Okay, let's look at some rules. Balancing chemical equations. First of all, write the unbalanced equation. On the left side of the equation, we have the reactants. On the right, we have the products. The arrow between them shows the direction of the reaction, and when we're saying that, we would say it yields something. Balance the equation. Get the same number of atoms of every element on each side of the equation. Balance the chemical equations by placing numbers, coefficients in front of them. Do not add subscripts, the little numbers, because this will change the formula. Once one element is balanced, proceed to balance another and another until all elements are balanced. Finally, indicate the states of matter of the reactants and products. Brackets, little g for gases, little s for solids, L for liquids, and AQ for species in solution in water, aqueous. Let's have a look at a worked example. Okay, calcium carbonate over here. Ca, calcium carbon oxygen 3. Yields calcium oxide plus carbon dioxide. This is a very simple example because it is already balanced. What I need to do is to write down all of my elements in the reactants, calcium, carbon, oxygen, down here, and indicate the number of each atom. On the other side, keep it consistent. Calcium, calcium, carbon, carbon, oxygen, oxygen. No matter what elements you have in the products and the reactants, make sure that they're listed in the same order. When we look here, we've got one calcium, indicated here with a 1. On the other side, we've got one calcium, also indicated with a 1. Carbon, 1 here for the reactants, and 1 on this side for the products. Oxygen, we've got 3 written here. On this side, we also have 3 oxygen, 1 oxygen atom in our calcium oxide molecule, and also 2 oxygen here as part of our carbon dioxide. Let's have a look at some examples. Let's go for the first one here. Okay, gaseous nitrogen and hydrogen combine to form ammonium. Okay, first thing that we talked about before, actually let's just bring this down a bit. Okay, write our reactants here. I'll just resize that. Show what it yields. Ammonia. Oops, what's going on here? NH3. Okay. Write down all of the elements on the left side. Nitrogen, hydrogen. On the right side, the same. Nitrogen, hydrogen. Okay. Noticing straight away, my subscript here is 2, which tells me I've got 2 nitrogen atoms. Likewise, I've got 2 hydrogens. On the other side, excuse my messiness here, nitrogen, I've got 1, hydrogen 3. Okay, straight away there's an imbalance. So what I'm going to do, and I'll change colours for this, I will put in a 2 over here. Straight away, this changes things. 2 nitrogen, 6 hydrogen now, because 2 times 3 is 6. Remember, you cannot change the subscripts, only the coefficients in front of the molecules or elements. Okay, problem. We've got 2, 2 here for nitrogen, but now 2 and 6 down here for hydrogen. What can I do to 2 to turn into 6? You can multiply 2 by 3. So I'm going to put a 3, let's make sure I've got the right colour, in front of my hydrogen, and write 6 here. Okay, So my answer will be, the balanced equation will be N2 plus 3H2 yields 2NH3. Okay, hopefully this makes some sense for you. In part 2, I'll balance some more difficult equations.